Good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. This is Suresh, Faculty of Chemistry. How are you all? Good afternoon. Richa Sharma, Annamani, Komal. Great to see you after a long time. How are you, Komal and Richa Sharma? Confirm whether you are able to see me. Can you able to hear me? Annamani, is it fine? Just give a thumbs up and fire emojis so that we can start the session about Arenes. Welcome to NEET STEP UP 2025 program. On this YouTube platform, Infinity Learn is offering you physics, chemistry, biology sessions right from 12 o'clock to evening 6 o'clock, and you all get advantage of these sessions given by eminent faculties, and also like and share, subscribe to our NEET channel. Are you fine? Good afternoon, Richa Sharma. Me fine, thank you. Very good. Nice to see. Okay. Good afternoon. Right. That's good. Nice to see good number of students in the session. And what Infinity Learn is doing for you guys. And this Infinity Learn by Sri Chaitanya is offering a NEET examination seat guarantee rank assurance program that you can enroll and you can join and you can get the best out of it. I am going to explain you the salient features of that and what we have done so far. And these are the students you can see from the slide, and these Ashrita and Akhil Verma, Satyanarayanan, Hemadyuti, they have taken a few courses from Infinity Learn, and you can check what they achieved. When NEET examination, Ashrita got just only 310 marks, and after studying with Infinity Learn, she secured 661 marks, and there is a huge impact. You can see 351 marks increment. Itna baat rahe. And Akhil Verma, he just secured just like that, and 313 marks in 2023, and he secured 658, and there is a 345 marks increment can be seen. And also Himadyuti just 310 marks and got 652, 342 marks increment. And Satyanarayanan, and he got 330 marks and increment of 650, and there is an increment of 320. And not only these four, and hundreds of students got like this, and you will be the next for these achievements. And how do they get it? And they joined in NEET STEP UP program, and you can see NEET 2025 rank assurance program, a batch which is actually commenced from the 16th August for NEET droppers. And these are the eminent faculties, including me and many pool of faculties from Infinity Learn, and you are going to exclusively get these salient features. And 480 hours of live class with complete NEET syllabus, and also downloadable notes after session and class recordings and DPPs. Dear students, you can see 5,000 topic-wise recorded videos by India's top NEET faculty, and chapter-wise previous year questions with video solutions, and we can test and their assessments, and you can get how the progress is going on when you're preparing for the exams, and full syllabus mock test with detailed reports. You can get it 24/7 doubt removal sessions, and wherever you have a doubt, whenever you have a doubt, you can get the doubts as such can be clarified 24/7. And 30 NEET Achiever Series premium printed books that will be reaching to your doorstep, and parent meetings will be there so that we can have a discussion how things are going and how can be done, and further progress kaise karna, sab isme discuss karne wala. And with this program in 2024 mein, there are 9 students who secured 720 out of 720 from the Infinity Learn. And you just see Achiever Series books are there. From there, whenever NEET examination is completed, we analyzed सारे के सारा पूरा questions from the Achiever Series में मिल गया. And you can see 45 students below 100 All India Open category ranks, and also 132 students scored in 700 All India Open category ranks. You can see and the strength of Infinity Learn by Sri Chaitanya with great pool of faculties, and you can do the best. है ना? Right. Then how to enroll in that? So simply you're going to direct, I just want to show you, this is our video, that is a YouTube platform. When the video is going on, my dear students, you can just scroll it up and you will be having a description below the video, and you can click on more. There you will be having the first link, that is boost your NEET score with Infinity Learn, enroll now, a link is given, and you all just click that link. You will be directed to a program and a page, and in the page you can see all the key features, a result driven scientifically designed program here. And in this result driven program you can see all comprehensive video lectures, personalized learning, detailed study materials, and targeted practice questions. Those practice questions we prepare in such a way that they are targeted for NEET examination. During a session and a post session you will be giving those questions, and a national level mock test we have, and performance benchmarking we have, and 10 plus Sri Chaitanya grant test benchmark against top performers from India's leading NEET coaching center. And you can also see efficient revision tools, and you can say expert doubt session, and also unlimited practice test also. So you will be directed to various courses that are available on the board, right? And you can click whatever the course that is given with always discounted price. When you click a buy now, you will be directed to the verifying phone number page. There you can verify your phone number, then you can get it, send OTP, then it will be directed to your payment gateway. And whenever you go for the payment gateway, you will be given a coupon code, that is Suresh 50, and in this you can say any course you can get a 20% discount. That what you choose, that coupon code is going to be Suresh 50, and if you apply Suresh 50 coupon code, whatever the course you take, flat 20% discount, then you can go for the payment of UPI card, net banking, whatsoever, so that you will be connected to Infinity Learn directly, and you will be our customer, and Infinity Learn is going to take care of you, right? And what late, everybody just try it once, and you are going to get an awesome journey with NEET preparation along with Infinity Learn. So we all rise together, right? So get ready. So your topic of interest is for today is Arenes. So without any delay, we'll do it. Richa Sharma, how are you? Richa Sharma, how are you doing? Nowadays you are not coming. I think you are busy with your school and college. Komal and Annamani and Abhinav is going to come a bit late. And what about Ishita? Where are you? Richa, so how about your preparation? You tell me. So I really appreciate you. Whenever you are not able to join the session, you are watching the recordings, I know it. And you are also joining the live sessions whenever you are convenient, right? So in this NEET Step Up 2025 program, YouTube sessions are there with Infinity Learn. Every day, Monday to Saturday, 1:30 to 3 o'clock, without fail, you all join. And any doubts, you can watch the recordings and you can add a comment to that. So every comment is going to be given an answer for that, right? Very good. So without any delay, we are going to discuss the subject. So we enter into what we learn from the Arenes. First, let us talk about the aromaticity, because Arenes is the topic today. Class of interest is going to be totally covered with half of the organic chemistry. So let's talk about what are arenes and aromaticity, introduction to the structure of benzene and preparation of benzene, and electrophilic aromatic substitution reactions of benzene, and direct to influence of monosubstituted benzene. And these are all the main course of the total arenes topic, my dear students. So get ready. Are you all? Yes. Ishita, hello, how are you? Ishita, I'm fine. How are you? Thank you. At least I can see Richa and Ishita together after a long time. So Ishita is coming every day. Richa is not able to attend the classes nowadays. So you can watch the recording, right? So we'll start. Aromaticity. So aromaticity, a compound to be said to be aromatic on what basis? So reactions, let us compare the reactions of alkene and alkyne. Most unsaturated compound, let's say this is an alkene. When this alkene is treated with cold alkaline KMnO4, आप क्या बोल सकते हैं? Cold alkaline KMnO4. This is what you call it as Bayer's reagent. इसका कलर क्या? इसका कलर क्या? इसका कलर आता है पिंक. ये वाला पिंक है. So due to this reaction, this alkene is hydroxylated, so that you are going to get a Mn2 plus. Mn2 plus का वजह से it is colorless. So what I mean to say, the pink color of the reagent is disappeared. This is a test for alkene, and alkyne also behaves like that. Okay, let's talk about alkyne. This is your alkyne. Alkyne react with cold KMnO4, and it is going to give its respective product, that is 2,3 diketone, butane diketone, okay, dione. So addition of Bayer's reagent to benzene, मान लो ये क्या होगा? So when you add benzene and Bayer's reagent KMnO4 in the alkaline medium in the cold condition, there is no reaction. There is no reaction. Why there is no reaction? दो बेंजीन इसका स्ट्रक्चर में आपका 3 डबल बॉन्ड्स है, लेकिन ये आल्कीन का जैसे रिएक्ट नहीं कर सकता, क्योंकि एरोमेटिसिटी का वजह से, रेजोनेंस का वजह से, डीलोकलाइजेशन ऑफ पाई बॉन्ड का वजह से. दैट इज द स्पेशल फीचर ऑफ दिस बेंजीन. So why it is so has to be discussed on the basis of the resonating structures of benzene, है ना? Resonating structures of benzene. So the benzene, the pi bond due to resonance, it is delocalized, है ना बेटा? And when it is delocalized, it is going to see the ring, the electrons continuously revolve in a circular path. Therefore it continuously seen its structure like this, okay, so that the pi bond is not ready for the addition process, rather it undergo substitution reactions. So that can be explained. If the direction of the ring current is diatropic, then the molecule is aromatic. This is the condition for the aromaticity. And if the direction of the ring current is paratropic, then the molecule is going to be anti-aromatic. So aromatic is more stable, but anti-aromatic is not at all stable. So we will discuss about aromatic and non-aromatic and anti-aromatic. Let's take classification of organic compounds or the cyclic structures. It is given as classification: aromatic compounds, anti-aromatic compounds, and non-aromatic compounds. So what are the conditions to say a compound to be aromatic, anti-aromatic, and non-aromatic? So let's talk about conditions for the aromatic compounds. Now there has to be a ring. So these are the 4 points. There has to be a ring. The structure supposed to be a cyclic structure, and the ring must be planar, and this ring should be structurally planar. No atom of the ring must be sp3 hybridized, provided that there shouldn't be any lone pair of electrons. So this point is conditional. This point is conditional. So if lone pair or negative charge is present, ignore sp2 condition. So that's very important. That's very important, because if lone pair of electron is there and negative charge is there, it is going to participate in the resonance, and it must be fully cyclic conjugated. Fully cyclic conjugated mean to say the resonance should be completely present throughout the ring. That is the meaning of the third statement, and it must follow Huckel's rule. There must be 4n plus 2 number of pi electrons. So this is what you call, say it is a Huckel rule. So if a compound obeys this first point, second point, third point and fourth point without any methane, so the compound is said to be aromatic. You have to check, if any structure is given, you have to check whether these 4 points are matching or not. So this is the condition for aromatic, and you can see various examples that I want to give you, and you can do the best. Yes or no? Now let us say how to say a compound. Let us say a benzene. Yes, let us say first point. Yes, first point is okay. And ring must be planar. Yes, ring is a planar. Her carbon atom benzene per sp2a, so that the ring must be planar. And second point is okay, and it must be fully cyclic conjugated. So it is fully cyclic conjugated. So you are going to get the resonance throughout the ring. So that third position is also satisfied. And let us talk about 4n plus 2 number of pi electrons. 1, 2, 3 pi bonds. 3 pi bonds means there should be 6 electrons. So that solve for n value. If n value is said to be an integer 1, 2, 3, it goes like this. Then the aromatic compound, the compound is aromatic. Mind it, 0 is also included in that. So if that is the case, if n is solid, is going to be 1, so that fourth point is also fine. So that benzene is said to be aromatic. Benzene is said to be aromatic. Is that fine? Clear? That's good. That's good. Any doubt, Ishita, Resha Sharma? And you follow these 4 points in the NEET examination based on aromatic and stabilities, you can get a question. Mind it, it's very important, quite important, right? Now one more thing, example, many are there. If n is equal to 0, then we will get the following: 4n plus 2 is equal to pi is equal to 4 into 0 plus 2 pi, 2 pi electrons. Therefore the ring with the 2 electrons is said to be aromatic. If you say similarly, agar n is equal to 1, there should be 6 pi electrons. Agar n is equal to 2 है ना तो 10 pi electrons रहना है, and n is equal to 3 होगा तो 14 pi electrons should be there. Fine, that's good. And also say benzene has a ring and all the carbon atom are in sp2, and it is cyclic and structure is planar and follows 4n plus 2, and as we solved it is going to be n is equal to 1. So benzene is said to be undoubtedly, perfectly, it is aromatic. And let us talk about some more. Note, if more than 2 pi orbitals are parallel and overlap simultaneously, then there is a conjugation. Given one of them filled with other is vacant, you can say the characteristics of the aromatic compounds. And one important, they have a characteristic smell. So every aromatic compounds will have a characteristic smell. Smell means aroma. So the compounds with characteristic aroma are said to be aromatic compounds. So they are extra stable, super stable, okay, and they burn with a sooty flame. They burn with a sooty flame. Lot of carbon deposit is there. Why they have the lot of carbon is present? Warren mystery. Okay. Okay. Attend the class. Warren Mishram. And sooty flame is due to high carbon to hydrogen ratio. That is very important. High carbon to hydrogen ratio. Due to that reason they have the sooty flame when they burn. And also talk about classification of compounds. We have aromatic, anti-aromatic, non-aromatic. Aromatic में आता है benzenoid aromatic and non-benzenoid aromatic. ये क्या चीज़ है? सो बेंजीन का जैसे लग रहा है कि compounds, that is called benzenoid aromatic compounds, and not other than benzene structures are called a non-benzenoid aromatic compounds. Can you give a name for a compound rich the benzenoid aromatic compounds का? benzenoid aromatic compounds का एग्जाम्पल दे सकते हैं? जल्दी जल्दी बताओ, जल्दी बताओ, एक एग्जाम्पल बताने तो काफी है. इशिता, yes, benzenoid and non-benzenoid aromatic compounds. I'll be giving the examples over here. Benzenoid aromatic compounds. So molecule having at least one benzene ring in the system is known as benzenoid aromatic compounds. So example, first one is benzene, we know it, and naphthalene, and anthracene, and phenanthrene. Number of pi bonds 1, 2, 3, 4, 5. So that number of pi electrons are 10. Anthracene, number of pi bonds are 1, 2, 3, 4, 5, 6, 7. So that each bond contains 2 electrons. So number of pi bonds are going to be 14. Phenanthrene, ये anthracene का sister है. So that you will be having 1, 2, 3, 4, 5, 6, 7. 7 pi bonds and 14 pi electrons. When you talk about 4n plus 2, 4n plus 2 should be equal to 10. When you solve, you are going to get a 2. है ना? Like that you solve it. You got an integer, so it is an aromatic compound. When you talk about 4n plus 2 should be equal to 14, on solving n value आपका 3 मिल जाएगा. So which is also an integer, so that it is an aromatic compound. Like that. Okay. Anti-aromatic compounds. अरे नॉन बेंजेनॉइड कहाँ है? ये नॉन बेंजेनॉइड आता है. एग्जाम्पल्स ऑफ नॉन बेंजेनॉइड, so that is what you call it as azulene. This is what you call it as azulene. Okay, so these structures let me give you example name as an azulene. इसका स्ट्रक्चर आप आगे स्लाइड्स में मिलेगा. ओके, जूलॉजी क्लास शाम को 4 बजे, शायद 3 बजे और 4 बजे. I think it is 3 o'clock. Okay, you are attending only zoology class, not chemistry class? Real? Okay, so you please attend physics, chemistry and botany, zoology classes, so that every subject balance you have to maintain, तभी आपको रैंक मिल जाएगा ना, है ना? Yeah. Even botany, now my network is too poor. No problem. Chemistry अभी attend किया ना. Chemistry में आज आपको aromaticity दे रहा हूँ. So when you do good in physics, chemistry and biology, everybody can do. So the rank determining subjects are chemistry and physics. You agree with me? Now you join with us and you enjoy the aromatic, anti-aromatic and non-aromatic and the structure of benzene, and also the preparation and properties and electrophilic substitution reactions of benzene with direct influence. You are going to get an awesome picture about total aromaticity. Mind it, you are going to get on Friday total arenes का multiple choice questions and Saturday का total hydrocarbons का multiple choice questions आपको मिलेगा. So that this week I just want to give more emphasis on the objective part. And in this NEET Step Up 2025 program, week Monday to Saturday, Suresh Sir का class है 1:30 to 3 o'clock. First 3 days, Monday, Tuesday, Wednesday, 11th standard का syllabus है. एंड थर्सडे फ्राइडे सैटरडे 12th स्टैंडर्ड का सिलेबस है. सो ये सभी सिलेबस में आपका सिर्फ नीट का डिस्कशन चलते रहते हैं. यू डोंट लीव दिस एंड it is your golden opportunity, you can get it. Let us talk about anti-aromatic compound. So anti-aromatic compounds, these are unstable compounds. So you don't have an attempt to make an anti-aromatic compound during a conversion, okay. And anti-aromatic compounds are super unstable and aromatic compounds are super stable compounds, है ना. And let's talk about conditions for anti-aromatic. They must be cyclic, they must be planar, and they should have complete delocalization. And the fourth point makes the difference between aromatic and anti-aromatic. There must be 4 n pi electrons where n is equal to 1, 2, 3 or so on, but not 4 n plus 2 number of pi electrons, है ना. In this 4n plus 2 number of pi electrons, it is said to be aromatic. If it is 4n electrons, it is said to be anti-aromatic. And you can have n number of discussions with that, okay. Let's do. And for example, 1,3-cyclobutadiene, 1,3-cyclobutadiene, it is butadiene. In this 1,3-diene in the cyclobutane, so it is the first point fine, second point fine, third point fine, and the fourth point you can see 4n plus 2 is equal to just 2 pi bonds, so that 4 electrons on solving n is equal to 1 by 2 is not an integer. If you use this is a 4n plus 2 Huckel rule is equal to pi electron on solving. If n is equal to not equal to an integer, then the compound is going to be anti-aromatic. Simple trick, है ना. Just let us go back and just let me give you the picture about it. Yes, it is. In this classification of compound, aromatic, first one is cyclic structure. First one is a cyclic structure. Second one is planar structure. Third one is complete delocalization. Complete delocalization means the resonance should be present totally throughout the ring. That is what you call it is complete delocalization. And fourth one is 4n plus 2 number of pi electrons. If a compound follows this point and this point and this point and this point, this is said to be aromatic. If you talk about the first point is okay, second point is okay, and third point is okay, and fourth point is not okay, then the compound is said to be anti-aromatic. Simple tricks. And non-aromatic, first point, second point, and third point. So if any one of the second and third point is not okay, the compound is said to be non-aromatic. Is it fine? Good. So you need to follow this kind of tricks and methodologies so that you can smoothly get NEET examinations rank, है ना. You study daily 18 hours, कुछ फर्क नहीं पड़ता है. कम से कम 8 घंटे का पढ़ाई करो, लेकिन इसी तरह करना, so that you are going to get result is going to be a byproduct and you will be a topper in the examination. My dear students, are fine? Okay, good to see great number of students. So I want to see in the chat box should be engaged. Richa, Gatewitch and Ishita, Annamani, fine. Now Let us go ahead with some more examples, Let's talk about non-aromatic compounds. Here about non-aromatic compounds, my dear students. Okay, right. So, example here it is a cyclohexane diene, 1,3-diene, and it is 1, 2, 3, 4, 5, 6. Hexane, 1 hexane, and these are all non-aromatic compounds. So, order of stability, aromatic compounds are extremely stable, then non-aromatic compounds, then anti-aromatic compounds, and I already mentioned you aromatic compounds are super stable and non-aromatic compounds are super unstable. I just want to say extremely unstable, they never exist. When they form also they destroy. And also based on aromaticity, which of the following is an aromatic hydrocarbon? Fatafat, answer fatafat dena. Classify aromatic and non-aromatic jaldi, kuch bhi na kuch answer dena. Richa Sharma, some answer Anamani. Here we already seen example, it is an anti-aromatic. Cyclobutadiene, and it is going to be naphthalene. It's perfectly aromatic because first point, second point, third point and fourth point, every point is accepted. Whereas this first, second, third, fourth points, you take first point, second point, third point is okay, but fourth point is not okay. And when you talk about this is sp3 carbon and this is an sp3 carbon, so it cannot be planar and there is no complete conjugation, so it is a non-aromatic. This is a non-aromatic. Okay, yeah, your answer is correct. So you can also say the same way, sp3 carbon atoms are there beech mein, so that you can say it is a non-aromatic. Non-aromatic. Samjhe? Now I just want to say, and options A, B, C, D, and this is explanation that I already explained you guys, right? You can go ahead with that. Any doubt in that explanation? Richa, you have given option B is the correct answer for with respect to that question, right? Okay. Now based on aromaticity और एक क्वेश्चन करने को तैयार है. Write the order of stability of the given compounds. Yes, you only have to give order, just write the order. Richa Sharma, give the order. Give the order so that we can, yes, it is aromatic, whereas this is anti-aromatic, and what do you say? Because of the sp3 carbons are there in between, so it is said to be non-aromatic. It is going to be non-aromatic. So we know that aromatic compounds are more stable than non-aromatic compounds are more stable than anti-aromatic compounds. So the order of stability is going to be 1 is more stable than non-aromatic compounds, 3 is more stable than 2. समझे? ऐसे क्वेश्चंस आपका नीट एग्जामिनेशन में सीधा निकालने वाले हैं. So all with us can do with a lot of confidence, my dear students. So you can see the order of stability with the same solution. You got it. Aromatic is more stable than non-aromatic is more stable than anti-aromatic, so that 1 is more greater than 2, 3 is than 2, right? Good. Fantastic. Based on characteristics of aromatic compounds, why do aromatic compounds burn with sooty flame? So they have a ring structure of carbon atoms, they have a relatively high percentage of hydrogen, they resist a reaction with oxygen or air, they have a relatively high percentage of carbon to hydrogen ratio. So that option D is going to be the correct answer, right? And simple छोटा मोटा क्वेश्चंस लॉजिक से हिसाब से पूछना के संभावना है, so that you all follow these lectures without fail. And one more, what is this quasi aromatic compounds? You have any idea about quasi aromatic compound, my dear students? Any idea about quasi aromatic? Okay, so actually a compound which is actually not aromatic, but due to its charge, due to its ionization, due to its ionic state, it is going to be aromatic. Such compounds are called quasi aromatic. Aromatic compounds in which the positive or negative charges present in the ring or part of occult rule are known as quasi aromatic. So in that you can say trophylium cation is an example, and cyclopentadienyl carbanion is aromatic. Okay, so these are all quasi aromatic compound. When you say trophylium carbocation, you just see this is the structure. If you see, this structure is a neutral structure. This is not actually looking like an aromatic, but when this oxygen is more electronegative, so this pi electron is going to be shifted. As a result of this, it is going to be converted into a structure like this, a structure like this. When it is converted into a structure like this, it is going to be like this. Now this is the positive charge. Now this positive charge is going to take part in its resonance. Now it is a cyclic planar system with complete delocalization is seen, and it is a 4n plus 2 is equal to how many? 3 pi bonds are delocalizing, so that it is going to be 6, n is going to be 1, and it is going to be aromatic. So such phenomenal structures are called quasi aromatic compounds, and this is an excellent example. A neutral molecule become a charged molecule, you can see. This is aromatic, so that equilibrium always try to favor in the forward direction. So they self ionize कर सकते हैं. And trophylium carbocation, cyclopentadienyl anion is aromatic, but cyclopentadienyl cation is anti-aromatic compound. Dear students, we are getting awesome content over here, right? You are all with us. Come on. And one more, cyclopropenyl cation, cyclopropenyl cation, and is an example. 4n plus 2 is equal to how many electrons are there? Only 2 electrons are there. On solving n is equal to 0, it is aromatic. That is going to be aromatic. Understand? So in the quasi aromatic compound, I just want to give you one more example. One more example, you can see cyclopropene, and it is conjugated with cyclopentadiene. So it is a neutral molecule, whereas this carbon to carbon double bond that is present between the two rings, a double bond rotation is restricted. But due to what happens, the electron may come over here, so that you will be getting a structures like this. So as a result of this, it is going to be a positive charge, it is going to be a negative charge. So both rings getting aromatic due to quasi-aromaticity property, so that it is a quasi-aromatic. And now you can see the carbon to carbon bond rotation is permitted. The carbon to carbon bond rotation, single bond is going to rotate, whereas double bond cannot rotate. So that the bond rotation makes it possible because of this single bond. The single bond is attained due to the quasi-aromatic nature. So the quasi-aromatic compounds, again, characteristics of quasi-aromatic compounds, they are highly stable and they have soluble in polar solvents. Why? Because they have the charges over here, dear students. They have high dipole moment, and because they have the high dipole moment and they have high boiling points and melting points because of the polarity. And it's very important, my dear students, you can do the best out of these kind of awesome explanations with good examples. Are you ready to see the more examples in the class? Right, Richa? Okay, let's talk about, based on the stability of the molecule, you can say out of these two compounds, which is more stable? It is benzyl cation is stable, trophylium cation, both are stable. It is stable due to resonance, and it is stable due to resonance also due to aromaticity. Among these, tropylium carbocation is more stable. Aromatic cations are more stable than the others, hence the tropylium carbocation is stable than the benzyl cation. Arey beta, you can also, this is aromatic na, but due to this positive charge, it is not aromatic. That's very, very important. However, this compound, this structure is aromatic, it cannot be stabilized by the phenomena of aromatic. Though benzyl carbocation has, उसमें भी रेजोनेंस है, उसमें भी रेजोनेंस है, लेकिन इसमें रेजोनेंस प्लस एरोमेटिक कंपाउंड is added advantage of it, है ना? It's very good example that you can see. And और एक चीज है, और एक चीज है, Richa, fine. हाँ, that's good. You changed your DP also. Good. Now let's see. Out of these two compounds, which is more stable? Benzyl anion and cyclopentadienyl anion, which is more stable? Yes, it is more stable. उसमें रेजोनेंस है, उसमें भी रेजोनेंस है, लेकिन उसमें रेजोनेंस फिर भी इसका aromatic character makes it is more stable. So more is the stable, more is the resonance, and more is the aromaticity, more is the stability, है ना? Right. Alright, sir. Let us say more questions. ये दोनों में कौन सा स्टेबल होगा? स्ट्रक्चर ए एंड स्ट्रक्चर बी. Richa Sharma, I want you to give the answer. I want you to give the answer. आज बहुत कम बच्चे देख रहे हैं सेशन में. अरे चार्ट बॉक्स में फटाफट देना आंसर. अगर ये होगा और बी होगा, जल्दी दे, so that we can start the preparation of benzene. Preparation of benzene. Yes. Annamani and Richa Sharma, either answer could be B. Yes, answer is going to be absolutely correct. Stability B is greater than A. क्योंकि the answer is, this is aromatic and this is anti-aromatic. You know the stability order. Aromatic is more stable than non-aromatic, is more stable than anti-aromatic. That is the key point behind this, right? That's good, nice. And the preparation of benzene, you can prepare it from alkanes directly. How do you get? If you take a cyclohexane, so when hexane is treated with C2Cr2O3 and Al2O3 couple and it is heated to 600 degrees centigrade, you are going to get dehydrogenated. By dehydrogenation, cyclization takes place and further dehydrogenation gives rise benzene. Okay. So, this is what you call it aromatization reaction of alkanes, aromatization reaction of alkanes. And also you can prepare by cyclic polymerization of acetylene, or ethane. 3 moles of acetylene, you can say 3 moles of acetylene is passed through red hot copper tube or iron tube ले सकते हैं, and you can say these C2H2 molecules are going to be cyclized to get C6H6. Why? Because the pi bond between acetylene is jumped between 2 molecules, so that a cyclic structure is obtained like this. So, this is what you call it as cyclization followed by aromatization. And also preparation of benzene from phenolic compounds. When phenol is treated with zinc, so deoxygenation takes place. I mean to say it is a reduction to form zinc oxide, and the product that we are going to get is a benzene. And also you can see the methyl substituted phenol. Okay, this is a cresol, orthocresol is going to give a toluene. This is methyl benzene. Simon, nice. Okay, where did you go so far, Simon? And let us say preparation of benzene from carboxylic acids by decarboxylation. Mixture of sodium hydroxide and calcium oxide mixture is called as a soda lime. When soda lime is heated with the benzene, so that it is going to be decarboxylated, so that a benzene is formed. Removal of carbon dioxide is called decarboxylation. And you can also say orthomethyl benzoic acid, decarboxylic acid heated with soda lime, and you are going to get toluene. Okay. And also preparation of benzene from Grignard reagent. When the what is the Grignard reagent? Alkyl magnesium halides or aryl magnesium halides are called Grignard reagent. When Grignard reagents are hydrolyzed, so that hydrogen is going to be there, and you are going to see the side product benzene along with MgCl and OH, like that. You can see various reactions of Grignard reagent with hydrolysis gives rise benzene. Fine, you all understand. Now, preparation of benzene, or important, benzene sulfonic acid, and it is treated with a superheated steam. Directly you are going to get benzene, and H2SO4 is going to be distilled out. And also you can say preparation of benzene from benzene diazonium chloride. How do you get this benzene diazonium chloride? And you see, what is this beta? Aniline, this is aniline. When aniline is treated with NaNO2 and HCl at 0 to 5 degrees centigrade, so that you are going to get benzene diazonium chloride. Dear students, this is your benzene diazonium chloride. This benzene diazonium chloride is reacted with H3PO2 or C2H5OH. You are going to get pure benzene like this. Got it? So, these are the reactions that you can see from the amines also, and it is very, very important. So, in the organic chemistry, conversion of one topic to another topic and conversion of one topic to one more topic, it requires a lot of effort. And I am going to give you the best out of these tricks. You all follow this, my dear students, so that you can get everything, right? And let us see benzene structure. So in this benzene structure, reactions of benzene is not like alkene. Why benzene is not reacting like an alkene? Though it has 3 double bonds in it, it is not reacting like an alkene because of the delocalization of the pi electron system. So if you see the structure of benzene, there are 6 hybrid orbitals. You can see carbon. Total thing I just want to explain: carbon, 1s2, 2s2, 2px, py, 1 1 and pz 0. When the carbon is get excited, so इसका इलेक्ट्रॉन यहाँ से यहाँ तक आना है, so that you are going to get 1s2, 2s1, 2px1, py1, pz1, है ना. Now we are going to see the combination of these 3 orbitals to give rise sp3. This sp3, 6 carbons undergo sp3 hybridization. sp3 का structure कैसे लगेगा आपको? sp3 का structure carbon, it is going to get 1, 2 and 3, and ये जो structure है ना, ये वाला इसका perpendicular होगा, है ना. So I just want to show you the structures. There are 6 carbon atoms that are there. Each carbon atom has sp3, 3 sp2 hybrid orbitals, so that 1 and 2 and 3, 1 and 2 and 3, 1, 2 and 3, and 1 and 2 and 3, 1, 2 and 3. It goes on like this. It goes on like this. When this is formed, there is a bond of sigma bond. There is a sigma bond, sigma bond, sigma bond, and there is a sigma bond. Now you can see hydrogen is going to make a bond over here. This is your hydrogen. This is your hydrogen, and this is your hydrogen, and this is your hydrogen, hydrogen, and there are 6 hydrogens. So far what happened, there are carbon to carbon sigma bond, it is a sigma bond, it is a sigma bond, and here it is a sigma bond, sigma bond, sigma bond, sigma bond. Try to understand the structure of benzene so that you can see there is a hexagonal structure like this, है ना, and hydrogen is like this, hydrogen is like this, hydrogen is like this. This is the structure, है ना, this is the structure, this is the structure, and this is the structure. And these are the carbon atoms, my dear students. This is the carbon. You can see colorful movie today, colorful movie today. But there is a pi electron system perpendicular to the plane of the triangle there. Plane of the, this is the plane of the triangle. Perpendicular to that, there is an unhybrid pure p orbital lies like that. And let us look into that p orbital that is present here, that is present here, that is present here, that is like this, है ना. Now we can see there is a overlapping of the orbitals, there is a overlapping of the orbitals, so that you got a structure like this. As a result of this, you can see, as a result of this, you can see a structure where there is a pi bond, there is a pi bond, and there is a pi bond like this, है ना. This is the structure of benzene, where hydrogens are not shown, where hydrogens are not shown, the hydrogens are shown like this. Due to this pi bond, they are in the conjugation, they participate in resonance. Understand? When they participate in resonance, what happens? These pi electrons are going to be isolated. So it is going to form a cyclic pi electron system, and due to this cyclic pi electron system, you can't add anything to that. Rather, you can take away this hydrogen, Therefore, the benzene do not undergo addition reaction, rather they undergo substitution reaction. That's very important factor, you need to know about it. Any doubt in that? Dear students, any doubt? Now, let's see. And you all remember my coupon code there. Okay, let me explain you one more time for that, how the things are going on. You can see when my class is going on, in this class, you can see on the video you have a description box. In this description box you have a first line, that is a first link. Boost your NEET score with Infinity Learn and enroll now, and click on that, so that the page is going to be directed and you can just see all the previous results, all key features of the course, and you will be given various courses that are available on the board, right? Courses for higher score and better score. Enroll the entire courses. You can see recommended, it is given here, right? Now you have only 9,000 rupees, and in this 9,000 rupees, if you just click it on, and you will be directed to a new page where you can enter your mobile number. When you enter your mobile number, our payment details will be there. You don't directly go for the payment, rather you can apply the coupon code that are available here. And what is my coupon code? You tell me, Annamani, what is my coupon code? When you apply Suresh 50 as my coupon code, 9,000 से इससे 20% कम आ जाएगा. So बहुत सस्ता में आपका NEET exam code Suresh 50, so that you are going to get 50%, 20% of the discussion. Okay, right. 1 minute. Yes. That's good. So let's go ahead. In the preparation of benzene is completed, and let us talk about the properties of the benzene. Reactions of benzene. Electrophilic aromatic substitution reactions of benzene. Electrophilic aromatic substitution reactions of benzene, that's what I am explaining you. Benzene, though it has 3 double bonds in it, it do not behave like an alkene. Why? It has the cyclic conjugation system. Rather, the addition reactions are not possible, rather substitution reactions are possible by electrophile. When you see most important reactions of benzene are electrophilic substitution reactions, these are all called as SE reactions. What are SE reactions? These are called SE reactions. SE means substitution electrophilic reactions. Okay, that is SEAR reactions. So let's talk about an electrophile. मान लो this Y plus is an electrophile, this is an electrophile. This electrophile is going to substitute the one of the hydrogen that is present on the benzene. So a replacement is taking place. This reaction is called as electrophilic substitution reaction. So various electrophilic substitution reactions are there. Let me give you the mechanism of this. In this mechanism, yes, the benzene, the pi bond is there and one of the hydrogen, and when electrophile is added, the pi bond is going to abstract this electrophile, so that it is going to give you electrophile and hydrogen, a positive charge is formed. And there was a pi bond become a sigma bond now, okay, and it is going to be stabilized by resonance, and it is going to be stabilized by resonance. कैसे होगा देखना है पर this pi bond is going to be shifted here. As a result of this, you are going to get a positive charge over here, and this pi bond is shifted over here. So, as a result of this, one more structure is possible, right? Now, its hybrid is going to be, positive charge and the electrophile and hydro. This is what you call it as a sigma bond, sigma complex. Sigma complex is the intermediate in its structures, right? And when this sigma complex loses the hydrogen, and it is going to give you the electrophile is substituted. So, this is what you call it as electrophilic substitution reaction. There are so many electrophilic substitution reactions that I want to show you, and the 5 most common electrophilic substitution reactions. One is a halogenation, a bromine or a chlorine or a iodine or substituents for hydrogen, and nitration, and NO2 group substitutes for hydrogen, and sulfonation, and sulfonic group is going to be SO3, H is going to be substituted for hydrogen, and Friedel-Crafts acylation and Friedel-Crafts alkylation, and acyl group is substituted for hydrogen, that is called Friedel-Crafts acylation, and Friedel-Crafts alkylation, alkyl group is substituted. So, we are going to look at these 5 reactions. Ready for that? Richa, come on. Anamani, what are you doing? And Simon and Ishita, what about Abhinav? Come on, I want to see in the chat box, should be active for you guys. Okay, let's talk about bromination or chlorination. So, bromine, when it is a halogen carrier, that is a Lewis acid is reacted, so that you are going to get a bromonium ion with FeBr4, and this is called bromination. Benzene react with Br2 FeBr3, you are going to get bromobenzene plus HBr. So, it is, what is the electrophile in the bromination? Br plus. In the NEET examination, which of the following is an electrophile in this reaction? It will be asked. It is a very simple question. The halogen carriers act as a Lewis acids. Very important, they act as a Lewis acid. What is Lewis acid? Electron pair acceptor. Reach out, right? Now, let's talk about chlorination. The electrophile is going to be chlorine plus, and this is a chloronium ion. This is an electrophile, and the reaction is benzene react with the chlorine in the presence of FeCl3, and you can also see BCl3 can also be used to get the chlorobenzene. Okay, and also iodination. Iodine in the presence of HNO3, it is an oxidizing agent, is very important. You are going to get iodonium ion, and this is going to give iodobenzene. Formation of iodobenzene is a reversible process. Reaction आगे बढ़ने के लिए HNO3 इस्तेमाल करना जरूरी है, because it is an oxidizing agent. And also you can see, note in iodination, oxidizing agent like HNO3, HiO4 are used to oxidize HI, a reducing agent. Also in presence of sunlight and the absence of halogen carriers, अगर AlCl3 नहीं होगा, मान लो FeBl3 नहीं होगा, BCl3 नहीं होगा, क्या होगा? You are going to see benzene is reacted with chlorine in the presence of light. You are going to see benzene hexachloride, BHC, okay, and this is also called as 666 compound, or he also said gamaxane. It has alpha, beta, gamma, like that. It can have total many isomers. In that, gamma isomer is important, that act as an insecticide. ये चीटी का इस्तेमाल कर सकता है. It is ant killer in the domestic ant killer. Okay, it's a very important compound, 666 compound. It may be noted that this is an addition reaction, not a substitution reaction. And nitration, it's very important. In the nitration क्या होगा बेटा? In the nitration क्या होगा? नाइट्रेशन में HNO3 plus H2SO4 react करने तो, so I just want to give you HNO3, so nitrogen, double bond O, single bond O and OH, and H2SO4, H2SO4 gives rise H plus and HSO4 minus, है ना. So this HSO4 H plus देके ये प्रोटोनेट बनेगा, so that you are going to get Lewis base. It is HNO3 is a Lewis base. मान लो, very important, this is a Lewis base. अरे HNO3 is a strong acid, ये base के तरीका react कर रहे हैं. Very important matter it is. Okay, so you are going to get OH2 plus. Now this OH2 plus H2O निकाल के आपका NO2 plus मिलेगा, nitronium ion. This is an electrophile. So this electrophile react with benzene to give rise nitrobenzene, and nitrobenzene is, yes, nitrobenzene is the chief ingredient in kind of any perfume, like you all use deodorants and perfumes, and nitrobenzene or nitrobenzene का derivative होगा, and HNO3 and H2SO4 ये जो mixture है आपके, मान लो it is a nitration mixture. This is what you call it as nitration mixture. ठीक है, and उसमें NO2 plus is an electrophile. NO2 plus is an electrophile. Fine, clear. प्रियंका सिंह, हाँ क्या बोलूँ मैं, क्या बोलूँ मैं? अरे चार्ट बॉक्स में सब ठंडा बैठ रहे हैं, कुछ भी ना कुछ बात करना है. And also I just want to say sulfonation. In the sulfonation, H2SO4 with fuming sulfuric acid इस्तेमाल करो, उसमें sulfur trioxide इस्तेमाल करना है. Sulfur trioxide is going to be the electrophile, so that what you are going to get, benzene, when it is heated with H2SO4 along with SO3, you can say H2S2O7, you can also say oleum. This is what you call it as a fuming sulfuric acid. When it is heated with fuming sulfuric acid, you are going to get a benzene. प्रियंका सिंह, क्या बोलूँ मैं, क्लास चल रहा है, अगर आपको कुछ डाउट है ना तो आप पूछ सकते हैं, है ना. Right. Now in this benzene sulfonic acid, you can see sulfonation of benzene is a reversible reaction. This is very, very important point for NEET examination. When you just, if the benzene sulfonic acid is heated in dilute sulfuric acid with again, and the reaction proceeds in the reverse direction, so that benzene sulfonic acid is heated, you are going to get benzene. है ना? Right? Fine. And Richa Sharma, any doubt? Priyanka, any doubt? Anamani, any doubt? Okay. So everybody kept quiet today in the chat box, and the class is almost about to end for today. And अगर doubt है ना तो पूछना. And introduction of alkyl or acyl group in the presence of catalyst, for that you require AlCl3, FeCl3, SbCl3. they act as a Lewis acid or a protonating agents, like you can also see HF, H2SO4, H3PO4. These are known as the Friedel-Crafts reactions. You can see in the Friedel-Crafts reactions, alkylation हो सकते हैं. Benzene is reacted with alkyl halide. In the presence of Lewis acid is going to get alkyl benzene. You can also see benzene with methyl chloride, you are going to get methyl benzene. What do you call it as? Toluene. It is what you call it as a toluene. And what is happening? RCl, this RCl lone pair of electron present on the chlorine is going to be act as electron donor, so that a Lewis acid base reaction takes place, so that R plus electrophile is generated. So this R plus electrophile is called alkyl carbonium ion. है ना? Right. Now Friedel-Crafts acylation. So you can also get this reaction in the presence of alcohol, in the presence of HF or dilute H2SO4, and alkene in HF or dilute H2SO4 at low temperature. कैसे हो सकता है? You can see CH3 CH double bond CH2, an alkene in the presence of HF. It is going to be, so you are going to get CH3 CH and CH3, so many ways. That's why I just want to give an example. Benzene in the presence of propene, you are going to get isopropyl benzene. This is isopropyl benzene. What do you call this isopropyl benzene? That is called cumene. So this is cumene. This cumene is an important compound in the cumene hydroperoxide method in the preparation of a phenol, commercial method. Remember, we discussed phenols also. Got it, beta? Yes. You can do in multiple combinations. That's what I just want to give you so much content for you. Okay. And acylation. जैसे आपका alkylation कर रहे हैं ना, आपका acylation when benzene is treated with acyl chloride in the presence of AlCl3, so we are going to get acyl benzene. Acylenium is an electrophile. Actually, the advantage of acylation and alkylation, polyalkylation takes place and rearrangement may takes place, whereas acylation, polyacylation do not takes place and there is no rearrangement. You see, the best is going to be acylation, है ना? And also I just want to say acetyl chloride can give acylenium ion. You can also say acetic anhydride, and you can also say when benzene is treated with acetyl chloride, you are going to get acyl benzene. So like that, you can use acyl chloride or acetic anhydride for that, and aryl and vinyl halides cannot be used for Friedel-Crafts reaction as they do not form carbocations easily. That's very important. Annamani, come on. We are going to summarize the session. Priyanka Singh and Risha Sharma, I want to see you actively participate in the session. And when you want to see, okay, substituted benzene, before going for that, I just want to give you, the overall picture about 5 golden reactions. Okay, this is your benzene, and this benzene is reacted with chlorine in the presence of AlCl3. You are going to get a chlorobenzene. This is what you call it as a halogenation, and you can also see nitration, HNO3 plus H2SO4. You are going to get a nitrobenzene. This is what you call as nitration. You can say H2SO4 plus SO3. This is what you call it sulfonation, SO3H. Okay, and also you can see or Cl in the presence of any Lewis acid like AlCl3, alkyl benzene is formed. This is what you call it as a Friedel-Crafts alkylation. And acylation you take acylation, or C double bond O Cl and the presence of AlCl3, you are going to get acyl benzene. So in this reaction sequence, what is the electrophile? Can you tell me, Richa Sharma and Anamani, Priyanka Singh, come on, what is the electrophile? इसमें electrophile क्या होगा? Cl plus is the electrophile, and इसमें electrophile क्या होगा? NO2 plus is the electrophile. उसमें electrophile क्या होगा? SO3, and उसमें electrophile क्या होगा? Alkyl carbocation is the electrophile, and उसमें electrophile क्या होगा? RC double bond O, and plus is going to be the electrophile. So in this session we discussed about all the aromaticity properties, aromatic, anti-aromatic and non-aromatic, and the stabilities and the conditions we have seen. And also I just want to say benzene preparation and benzene structure and the properties. Rehan Rajpura, yes, Rehan, you kept quiet in today's class, okay. And also we have seen all the reactions like halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, and their mechanisms, and उसमें क्या electrophile चल रहे हैं, Cl plus NO2 plus SO3 R plus and RC double bond O. All things we have seen. In the next session we are going to see and the directive influence of this, and also we'll talk about the hydrocarbons most expected questions. Stay with us, and we are going to complete our session now, and you all like the sessions, and share with your friends and subscribe to the channel, and also don't forget to join in rank assurance program given by Infinity Learn by Sri Chaitanya. There you can see everything I have shown you, in this my session. In my session you can see yes, you can see in the description box, the first link is in infinitylearn.com, and boost your NEET score with Infinity Learn. Enroll now. A first link will be there, and you can click it on, and once you click it on, you will be directed to various courses where you can click buy now. When you can go for the payment gateway, I have already given you my coupon code. You can add this coupon code, and you can get a flat of 20% discount whatever the course you enroll according to your wish. 20% discount, Suresh 50. Don't forget about this coupon code, and try to get a relevant course, and the course you like it, don't forget the coupon code Suresh 50. And tomorrow we are going to meet with more stuff. We are going to meet with more stuff in tomorrow's class about hydrocarbons. Till then we will meet many things, okay. So yes, thank you very much, Rohan. Today we have lectures of open schooling. That is why no, okay, that's why, not an issue. Try to attend the class. Tomorrow's class is also very important. Today we are done with the day. Okay, thank you very much. God bless you all. We'll see you tomorrow. Bye bye.